So a particle is thrown upwards from a ground. It experiences a constant resistive force that produces a retardation of 2 meter per second square. The ratio of time of ascent to time of descent. So what you here need to look at is, if you are throwing an object vertically upwards, what happens? The retardation is always, the acceleration is always g downwards. When it goes up to a height h, so what happens here? Suppose the distance traveled is h, so you can write it as, here its velocity becomes 0, and the free fall, when it falls down, h is equal to half g t square. So the time of ascent and time of descent will be the same, but because it is a resistance force, it is always opposite to the direction of motion. Suppose when you are throwing it up, so upwards vertically, so in addition to gravity acting downwards, the resistive force that produces a retardation of 2 meter per second square, let us say A, that is also acting downwards. So the total acceleration downwards will be g plus A. Hence, instead of writing h is equal to half gt square, suppose if the body rises to a height of h, so the same h can be written as half into g plus A into time of ascent square. Suppose when it falls down, g is acting downwards, A is acting upwards. Hence, in that case, since it is falling from the same height, so h is equal to half into net retardation downwards or acceleration downwards is g minus A into time of descent square. Since their left hand sides are equal, we can write it as half into g plus A into time of ascent square equal to half into g minus A into time of descent square. Cancelling that, time of ascent to time of descent equal to root over g minus A by g plus A, that is equal to root over 2 by 3. Since 2 by 3 is less than 1, time of ascent will be less than the time of descent, because while coming down, effective retardation is less than g, while going up, effective retardation is greater than g. So it gets up quickly to the highest point and it comes down slowly when it comes down with a resistive force.